Hello, my friend. How are you? Yesterday, I got a drawing from the customer, and in the drawing, I see that the park has a dovetail slot. Wow, the angle is drop about 7 degrees, so I am unable to find any dovetail cutter in our warehouse. So we need to find a supplier who can do the grinding job to make us a custom tool to cut that dovetail. But uh, the park is just a sample, and sometimes the customer always want to get a sample as soon as possible, and you don't have too much time to wait the supplier to grind the tool. So sometimes that is really a problem when we need to wait for the supplier, the tool supplier, to grind the tool for us. So, but luckily this time, uh, our tool supplier just needs about five days to grind the tool for us. But I talk about an idea, but I haven't tested yet. That's I don't know if we can use a boring bar. A boring bar is used to making hole on the lathe. So I think we can use a boring bar with a 55-degree insert, or even um, 35-degree insert to mill, to put the boring bar on the milling machine, and then we use it at a fly cutter. And I think we can use that tool to cut this dovetail using the 3D toolpath. So in this video, I will show you how to use a boring bar to cut this dovetail. But please remember that I haven't tested it on the machine, so because I don't have a chance to test. But I hope if you have the tool and if you have the machine, you can help me to test it to see if it's work or not. I'm very appreciated. Yes, please try it. I hope you can give me a result to see if it's work or not. Just need a boring bar for the lathe, sample drawing with the dovetail slot, and a milling machine, so we can test it to see if it work or not. Okay, for example, this is the part. You can see, sorry for the logos because some guys is taking my video and put it in their training DVD, and so I don't want to they take it. That's very sad. So I make this small logo here with my name, GTT. Okay, you can see this is a sample part. For example, we have a 20 degree dovetail slot here, and you can see the distance from this edge to this is measured about 0.088. So you need to select a boring bar that can machine this, can have a clearance greater than this distance. So you can check your tooling, and in this video, for example, I will go to the Iskag website. Okay. Iskag doesn't pay me for this. All right, and you can see this, the website iskag.com, e-catalog application, and you can select the ISO turning here. Then we look up for boring bar. So here's this. In this area, you can see there's many type of boring bar. You can select a 30 uh, 35-degree angle boring bar, or 55-degree angle boring bar. This case, because we want to make this milling machine, so I need I think I should find a strong insert. So 55 degree is maybe better than 35 degree. So I click on this. You can see here it can provide you some kind of boring bar. For example, I will check this one. You can see that. All right. We first we check the dimension of the groove of the slot first. So I do a measurement. Okay. First we need to measure the width of the slot. Okay. In this case, it's 0.8 inch. So we need to find a suitable tool for this. All right. Let's take a look. They have show you the dimension. Okay, let's take a look, and I will try this one. You can see this is the parameter of the tool. You need to check it with your park to see if it work or not. I think this is work for my park, so I click on this, and you can see that Iska tooling allow you to download the drawing of the tool in 2D, also 3D, and some other tool supplier, well-known tool supplier maybe provide like Iska. So I'm using the Mastercam 2017 or Mastercam 2017. So this allow you to use a step file to define the cutting tool. So that's great compared to the other previous version. It just allow you to select a DXF files. That's take time, but with Mastercam 2017, you just download the step file. Okay, here I will download the 3D model lights. I don't need a detail tooling because there's no need. Okay, I will download this file. Save link, yes. Okay, I will download it in my desktop, and I name it is car boring bar. Alright. Ping. And then save it. Okay, before I use the tool, I will import this to Mastercam for you to see what this look like. Okay, we go to the file and merge and look for the tool here. Yeah, you can see the tool has been imported to Mastercam. This is the boring bar. Oh, it's very long. Maybe when you need it, you need to cut it. Or maybe use some way to make it softer. It's too long. Oh man, you can see this is our boring bar with the insert attached. You can see this is the 55-degree insert with the corner radius of let me check. We need to check the corner radius. Alright. Right. I press F4 and click on the radius. You can see this is the radius of the insert. It's about 0.4 millimeter. Okay. So you can see we got a tool. To use a step 5 for the tool, you can download from the tooling maker, or you can draw it yourself. You can draw a tool and save it as step file. But please remember, you need to put the tool along with the z-axis. You can see here the tool is like along the z-axis. Okay, I can delete this one. Oh, before I delete it, I want to show you if this tool will fit our part or not. So I will do a transform to make it see. if it's suitable or not. Okay, make it here. I will show you to see. Alright, let's check. You can see it's smaller than our slot, so it's we do a 3D toolpath to make the tool go from here to here like this. And ping, yeah, stop here. I don't know if it's collision with the part. We need to try. Oh, maybe not. I think it's not collision. But one thing you need to remember, because the insert have a corner radius here, so with the Dovetail groove, if the customer allow the corner radius, you can use this into a radius insert of very small radius. Okay, so that this tool may work. I will delete it. No need it now. Alright, so the next step, I will create a tool. Alright, we go to the, oh, where is it, machine. We need to select a machine first, so I will select a mere default. Okay, and then I go to the tool manager here. Now you need to create a new tool. Right click and then select create new tool. Okay, you can select an MU, choose MU to create, and then I'm gonna click on next button. Alright, you can see this is our MU. So now I don't want to create an MU. I just want to use the step file I just download as my tool. So how to select a step file to make the tool? Here you can see there's a button that's allow you to select the step file for the tool. So you can click on this and file for the step. Oh, I see. So I will select the Iska boring bar step file I just download before, and then double click on this. Mass, you just wait to Mastercam to calculate and spin the tool to make a full profile. So you can see this is our tool. Why you see that's not the same with the file we just export? Because Mastercam, we take the tool and spin the 360-degree to make this one. So when our tool rotate, it will create a profile like this. So this is like the tool profile. So no different. This is the boring bar after Mastercam rotates. Alright, you can see the diameter of the tool. Cutting diameter is 0.7087. Yeah, and then we don't need to modify anything because this is exactly the diameter of the tool when it's rotated. So left is alright. And we need to one thing we need to make it a corner radius. You must define the corner radius of the tool in order to make it run file. But I will leave it first to see if it works or not. If it doesn't work well, I will change this parameter to modify the corner radius of the tool. Okay, we're gonna click on finish. So we got this tool and name it boring bar. Alright. Ting ting, yes. You can input the cutting parameter like this one. Okay, I'm gonna click on finish button. Alright. The fastest way to create a toolpath for a Dovetail cutter. So I will use a 3D toolpath to machine this face, this type of face, and this type of face. So, for example, I have already machined the slot. with an end mill, a flat end mill. So I got the, I will turn on this. So I have a level of corn stalk. You can see the stalk here. I will hide the part. For example, first I will do a rough cutting with a flat 10 mil to make a slot like this, a square slot. So after that, I will use the boring bar to make the dovetail section here. And I will turn on the part. Rough milling with a flat 10 mil and then use a boring bar to cut the section here for the tapper. Okay, I will turn off the stop. We will use it to when we verifying the toolpath. Okay. For the next step, we will create a toolpath to machine the tapper surface of the dovetail. Okay. Mm. Oh, my favorite toolpath here. I will use the 3D flowline toolpath. Okay. Here, the flowline toolpath. Bing. The first, select the surface you need to machine. I will turn on the solid selection here and gonna click on this face, click on this face, click on end selection. So we click, I'm gonna click on the flow button here to select the cutting direction. This is the direction I don't want, so I click on this, and this is our cutting direction. I will turn on the wireframe, but we don't want the tool cut from the bottom to the top because it's very heavy cut. So we change the step direction. Here we will cut from the top to the bottom. Alright, and maybe that's all. I'm gonna click on the OK. Then I select the tool, the boring bar for the tool path. I'm gonna click on the surface parameter, feed plane to retract. Okay, stop to leave on dry and stop to leave on check. You can use a tool to do the roughing and one tool to do the finish. That's up to you, but in this case, just want to show you how it works. Okay, I can make a direction to make a lead in motion for the tool path. Okay, plug angle 0 degree, make the angle 90 degree, plug length maybe 1 inch to plan x-axis. Okay, and go to the finish flow line parameter. We select the step over for the tool path. In this case, I will select assemble 5. Okay, the cutting method is zigzag, and to make it work, you need to uncheck this option. You need to unselect the check flowline motion for golf. And in the gap setting, I select the transition to direct, and you need to uncheck the check gap motion for golf here in order to work. I can make the toolpath longer. Input 0.1. Okay. 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 Oh, I just forgot to select the check surface for the toolpath. Oh my god. Again, I select the wrong tool blend because I looked apart from the front, so Mastercam automatically select the front for the tool blend, so I need to change it to top face. Okay. Bing! Yeah, 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 yeah. Dang, 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 dang. That's cool, right? see. Oh, I need to select the check surface. Okay, I check surface here. I will select the floor surface. Check so the tool will not go further than this face. Okay. Then what I just do. Okay, we make a let in and let out for the tool pad. The direction. I have a video to talk about the let in and let out for 3D tool pad. You can check it on my video. Okay, that direction. Let's see how it works. Bang! Bang! Go, 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 go! Oh, change the direction, the angle. Zero. Um, um. Yes. Yeah. Oh, it's work like a champ with lead. Oh, 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 oh. What's up? What's up? What's up? Oh, 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 oh. Man, the lead in, no problem. But the let out, you can see the let out. The tool we got here. Oh man, why? Why? Oh, the tool retract here. Oh, that's not good. I haven't found a way to solve this, so the best thing I can do now is make it bigger more than the diameter of the tool. For example, point 75. At least the tool not retract on the part. Okay, maybe okay, so we can move the direction. No let in and no let out. Okay. Ooh. Mastercam. Oh, it keep retract here. How to solve this? How to solve this problem? Maybe modify the program by hand. Oh my god, how to solve this? Let's check. Okay, check this option. See that work or not? Ooh. Wow, cool. Yeah, that's cool. So we can make it boys 01. Oh yeah, and then to activate the let in and let out. Oh, oh, oh. Yeah, yeah, yeah. That's what we want. Yes, that's what I'm talking about. So to make it work, you go to the uncheck this option, go to the gap setting, and uncheck this option and this option. Yes, make it let in and let out so it work like a jam. Yeah, alright. Yo, now I will do the verify, turn on the stock level, and go to the toolpath stock setup, check solid, and click on stock here. Okay, so we got a stock. We do the verification. Alright, that's what I'm expecting to see. Bing, bing, yeah, yeah, yeah. Let's just cut. Go. Ing, 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 ing. Oh, surface finish the poor. But I think you can use a smaller step over, and then you need some sandpaper. So we got the dovetail successfully cut. But you can see because the tool had the corner radius, you can see here we don't know the sharp edge at this floor. Okay, yeah. So in theory, we can use the boring bar to machine a dovetail, but there's some problem first because the tool just contact the surface by the corner radius, and the corner radius of the insert normally very small. So the surface finish of the dovetail may not be good, but you can change the step over to very small and do some sanding. Yeah, sandpaper may work. It's not a problem when you do a sample. You can spend more time on a sample if you can find a dovetail cutter at the moment. So this may be a solution for this. So as I talked about, I hope some of you can help me to test it on real machine and real stock to see how it works, and I'm very appreciated. So that's all for now. Thanks for watching. Goodbye and good night. It's Quietly here. Thank you everybody.